Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Alia Kistina binti Tua from tutorial FD2 with college ID KMK 2401-283. Will be presenting diffraction of light by single slit in compact disc, or also known as CD. Do you know what is diffraction of light? Diffraction is a fascinating wave phenomenon that occurs when light bends and spread out after passing through a narrow slit or around an obstacle. This spreading confirms that light behaves as a wave and not just as particle. It's one of the key pieces of evidence in the wave theory of light. When a beam of light passes through a single narrow slit, it forms a pattern of alternating bright and dark bands on a screen. This is called a diffraction pattern. At the center is the brightest region, the central maximum, and on both sides are dimmer bright bands separated by dark region called minima. And here are few key concepts of physics in this topic. The first one is central maximum. Central maximum is the brightest and widest fringe at the center of the pattern, resulting from constructive interference of wavelets traveling nearly the same path. However, the intensity diminishes as we move away from the central maximum, where secondary maxima and minima will form. Minima occur due to destructive interference, while secondary maxima occur where partial constructive interference happens. Next is pattern dependence. The width of the central maximum and the spacing of fringes depends on the slit width and the wavelength of the light. Intensity distribution. The intensity of the diffraction pattern decreases as a function of angle. The central maximum has the highest intensity and subsequent maxima become dimmer. And last but not least is the condition for minima. The condition for destructive interference or minima in single slit diffraction is given by this formula. A sin theta is equal to m lambda, where A is the slit width, theta is the angle to the dark fringe, lambda is the wavelength of light, and m is an integer. This equation helps predict where the dark fringes will appear on the screen. Now let's apply this concept into real-life application, which is compact disc, also known as CD. So how does diffraction of light occur in the CD? Have you ever wondered? A CD is made of spiral tracks with pitch and length. These tiny features are about 1.6 micrometer apart, which is similar to the wavelength of visible light. When light shines on the CD, it reflects from these tiny features, causing interference and diffraction pattern. A CD acts like a reflection-diffraction grating. The closely packed tracks diffract light, bending and separating it into colors. That's why we see rainbows when we tilt the CD under the light. This behavior is similar to single-slit diffraction, which both rely on interference caused by closely spaced features. A red laser with a wavelength about 780 nanometers is used to read CD. The laser shines on the CD surface and reflects differently depending on whether it hits a pit or a land. These differences are read as digital data, which is ones or zero. Diffraction plays a key role in keeping the laser precisely focused on the track. Diffraction allows a large amount of data to be stored in a compact space, helps the laser to stay on track, and ensure accurate data reading. Without diffraction, modern optical storage systems like CDs wouldn't function. Single-slit diffraction has many applications. It is in material analysis, quality control, astronomy, and nanotechnology. By analyzing how light spreads, scientists and engineers can better understand the structures and the properties of various materials. In conclusion, diffraction of light by a single slit shows how waves interact and spread. It's not only a beautiful scientific concept but also the backbone of modern technologies, For example, CDs. Understanding it connects classroom physics to real-life application, proving that science is everywhere around us. This is the list of my references to prepare this slide. Thank you for listening until the end.